Earth based on telescopes. Telescopes are designed to collect a certain type of electromagnetic waves. Some detect visible light and others detect radio waves and microwaves. Optical telescopes, like your eyes, optical telescope gather only visible light. There are two kinds of optical telescopes: refracting telescopes and reflecting telescopes. Both are shown in the figure on the right. Refracting telescopes. Have you ever used a magnifying lens? You might have noticed that the lenses are curved and thick in the middle. This is convex lens. A refracting telescope uses a convex lens to concentrate light from a distant object. The object you are looking at, the light goes through the object lens and refracts, forming a small bright image. The eyepiece is a second lens that magnifies the image. Reflecting telescopes. Most large telescopes use curved mirrors instead of curved lenses. A reflecting telescope uses a curved mirror to concentrate light from a distant object. It reflects light from a primary mirror to a secondary mirror. The secondary mirror is tilted to let you see the image. Larger primary mirrors produce clearer images than the small mirrors. Very large reflecting telescopes have many small mirrors linked together to make a primary mirror. For example, each 10-meter primary mirror in the Twin Keck telescope on Hawaii's Mauna Kea consists of 36 mirrors. Radio telescope. An optical telescope collects visible light waves. A radio telescope collects radio waves, and some microwaves use an antenna that looks like a TV satellite dish. These waves have long wavelengths and carry little energy, so radio antennae must be large to collect them. Radio telescopes are often built together and used as if there were one telescope. Computers convert radio data into images. Distortion and interference. Moisture in Earth's atmosphere can absorb and distort radio waves. So, most radio telescopes are located in deserts far from radio stations that emit radio waves. These radio waves can interfere with radio waves from space. Water vapor and other gases in Earth's atmosphere also distort visible light. Stars seem to twinkle because gases in the atmosphere move, refracting the light. This causes the location of a star's image to change suddenly. At a high elevation, Earth's atmosphere is thin. This produces less distortion than at low elevations. So most optical telescopes are built on mountains. New technology called adaptive optics reduces the effects of atmospheric distortion even more. Wings lens for space. Radio waves, microwaves, infrared waves, visible light, ultraviolet waves, X-rays, gamma rays. Space telescope. Why would astronauts want to put a telescope in space? The reason in the Earth's atmosphere, as the figures above reach Earth's surface, other types of electromagnetic waves do not. Earth's atmosphere absorbs some type of electromagnetic radiation. Telescopes on Earth can collect only the electromagnetic waves that are not absorbed by Earth's atmosphere. But telescopes in space can collect energy at all wavelengths, including those that Earth's atmosphere would absorb, such as most infrared light, most ultraviolet light, and X-rays. Optical space telescopes. Optical telescopes collect visible light on Earth's surface, but they work better in space. This is because of Earth's atmosphere. As you read earlier, gases in the atmosphere can absorb some wavelengths, but in space there are no atmospheric gases. The sky is darker and there is no weather. The first optical space telescope, called Hubble Space Telescope, was launched in 1990. The Hubble is reflecting telescope that orbits Earth. Its a primary mirror is 2.4 meters inch diameter. At first, images from the Hubble were blurred because of a flaw in the mirror. In 1993, astronauts repaired the telescope. Since the Hubble telescope has sent to Earth's many spectral energies of faraway objects. Using other wavelengths, the Hubble Space Telescope is the only telescope that collects visible light. Dozens of other space telescopes operated by many different countries gather ultraviolet X-rays, gamma rays, and infrared light. Each type of telescope can point at the same region of sky and produce a different image. An image of a star can be made by combining optical, X-ray, and infrared data. Different colors in the images represent the different wavelengths of materials in the star. Spitzer space telescopes, young stars and planets hidden by dust and gases cannot be viewed in visible light, but infrared wavelengths can go through the dust and show what is beyond it. Astronomers can also infrared to observe objects that are too old and too cold to emit visible light. In 2003, the Spitzer Space Telescope was launched to collect infrared waves as it orbits the Sun. James Webb Space Telescope, a large space telescope scheduled for launch in 2013, is also designed to collect infrared radiation as it orbits the Sun. The James Webb Space Telescope will have a mirror with an area 50 times larger than Spitzer's mirror and 7 times larger than Hubble's mirror. Astronomers plan to use the telescope to detect galaxies that formed early in the history in the universe. Electromagnetic spectrum. The entire range of radiant energy carried by electromagnetic waves. Radio telescope, a telescope that connects radio waves and some microwave using an antenna that looks like a TV satellite dish. Reflecting telescope, a telescope that uses a curved mirror to concentrate light from a distant object. Refracting telescope, a telescope that uses a convex lens to concentrate light from a distant object.